Good morning, ladies and gentlemen. I am Isama Simon Ukwenya. I am here to present a paper titled Design of a Batch Anaerobic Reactor for the Production of Biogas from A.B.U. Wastewater Treatment Plant, Zaria. Being a conference paper presented to the 2020 Sustainable Engineering and Industrial Technology Conference of the Faculty of Engineering, University of Nigeria, Nsukka. Please find attached my presentation outline, which includes introduction, review of related literatures, statement of research problem, the aim and objectives of the research, the scope of the research, the justification of the research, the materials and methods used for the research, as well as results and the discussion of the results. Introduction. Wastewater is water that has been used and discarded and is presumed to contain impurities such as suspended solids, dissolved organic matter, inorganic salts, heavy metals, and soot, according to the work of Pevy and others, 1985. Sewage sludge consists of byproduct of wastewater treatment, according to Usman and others, 2020. Globally, the generation of municipal sewage sludge has increased with rapid industrialization. Wastewater sludge contains a variety of organic and inorganic compounds, and as such, treating wastewater is one of the biggest challenges facing numerous industrial plants in Nigeria today, as every plant must allocate a significant budget to treat wastewater to keep the environment clean and safe, according to the work of Ogumbi, 2011. Biogas is a gas obtained by anaerobic decomposition of organic waste such as vegetables, plants, crop residues, human and animal waste, and consists of methane as a major component, with impurities such as carbon dioxide, nitrogen, hydrogen, and hydrogen sulfide. Biogas is somewhat lighter than air and has an ignition temperature of approximately 700 degrees centigrade. The main constituents of biogas are methane and carbon dioxide gases. Biogas burns very well when the methane content is more than 50%. The following are uses of biogas. It is used for running internal combustion engines to generate electric power, for cooking and lighting, as automobile fuels, as fuel cells. It is used for the production of chemicals. Residual sludge from biogas production is used as organic fertilizer for agricultural purpose. According to the work of Igboro SB 2011, biogas conserves the natural resources such as cutting trees to get firewood. Materials and methods used for the research. The materials and equipment used for the research include a glass beaker, digital pH meter, oven, thermometer, weighing balance, incubator, glass rod, Lovibond apparatus, and Kegel apparatus. Also, the following equipments were used for the research: a 3-liter bioreactor, which is locally fabricated by the researchers, a 1-liter graduated beaker, 10-liter plastic buckets, a 5-kilogram weighing balance, disinfectants, soaps and detergents, as well as surgical hand gloves. Figure 1. Methodology for the research. Characterization of Ahmadu Bello University Wastewater and sewage sludge. This involves sample collection, sorting and composition analysis of the sample. Hence, characterization of the wastewater and sewage sludge into their individual components using the following criteria such as dissolved oxygen, biological oxygen demand, chemical oxygen demand, ammonia, total dissolved solid and total suspended solid, as well as determination of moisture content, ash content, ultimate analysis, proximate analysis, biological oxygen demand, chemical oxygen demand, total suspended solid, and volatile suspended solid. Continuation of methodology used for the research. Figure 2 shows procedure for biogas generation from Ahmadu Bello University Wastewater and Sewage Sludge Treatment Plant. The procedure involves literature digest on lab-scale batch reactors, including kinetic data generation, construction and fabrication, as well as settling up a lab-scale batch reactor, biodigester loading with wastewater and sewage sludge in mixed and appropriate ratios, biogas generation and data recording, as well as data analysis. Continuation of the methodology used for the research. Figure 3 shows kinetic data generation from experimental data. This includes generation of kinetic data from the experimental setup, software analysis using Microsoft Excel server to generate and validate the kinetic coefficient and models being tested, the model selection using monode, Logistic and Contois model, and finally fitting experimental data into selected kinetic models. Plate 1 shows full view of digesters experimental setup, including the biodigesters inserted in a water bath maintained at a fixed Mesophilic range of temperature, which is 37 degree temperature, used throughout the duration of this experiment. Results of the experiment. Table 1 shows characterization of Ahmadu Bello wastewater used as biodigester context. Continuation of results gotten from the experiment. Table 2 shows the volume of biogas produced daily, including daily production of biogas and cumulative volume of biogas produced after 5 days. Also recorded in the table is the pH of slurry before digestion, as well as pH of the slurry after digestion. Continuation of the results gotten from the experiment. Table 3 shows characterization of the substrate and comparison with the digestates with retention time for biogas generation. This table shows the substrate percentage composition as well as digestate percentage composition with percentage increase and decrease where applicable. Continuation of the results. Table 4 shows goodness of fit for the two empirical models used for the verification of experimental data. The square of the correlation coefficient of both Contois model and logistic model, which were models used to verify experimental data, is tabulated and recorded. Figure 1 shows daily volume of biogas produced across the bioreactors. The volume of reactor content across reactor A to G is recorded with the corresponding volume of biogas produced across each reactor over a 5 days retention period gotten before each reactor is dismantled. Figure 2 shows the relationship between solid retention time and digestate. The solid retention time and the concentration of digestates were plotted, and the relationship that exists between the two shows a straight line downward sloping curve. Figure 3 shows total solids utilization for the substrates digested. The reactor contact with slurry across reactor A to G is plotted against the total solid generated, and the square of the correlation coefficient is noted. The equation describing the process being experimented is also recorded. Figure 4 shows fitting experimental data into the logistic model to indicate the best fit line over a 40 days retention period. Figure 5 shows fitting experimental data into monode kinetic model. It can be seen that the equation describing the process, which has been inscribed, and the square of the correlation coefficient given as 0.5796. The cumulative volume of biogas produced is plotted against the solid retention time. Discussion on results. Figure 2 to 3 shows the effects of heating and retention times on the volume on the biogas production from the feed materials. According to Rajendra and others 2014, hydraulic retention times vary between 20 and 100 days for mesophilic household digesters. Studies, however, show that decreasing hydraulic retention time from 90 days to 60 days and the biogas production from this experiment showed the good quality of combustible biogas heat. From the plot of figure 3, there is a significant difference in the retention time and their interaction. There was significant difference in the gas volume at all retention times investigated for 8 hours and 16 hours heating times. The highest gas volume produced was 0.929 was obtained over heating time of 8 hours daily for a retention time of 30 days. Whereas the lowest biogas volume was 0.0034 cubic meter, which was obtained for conditions of less than 8 hours heating time and a 2-day retention time. It was observed from table 8 that the gas volume utilized increased with increasing heating time at all retention times investigated. This is in agreement with the work of Ganiyu and Samuel 2015. Also, table 4 shows high and increasing values of chemical oxygen demand and volatile suspended solid of digestates compared to initial substrate concentration, and this indicates high bacterial metabolism corresponding to the high ratios of chemical oxygen demand versus volatile suspended solid plotted in figure 1, which describes the bacterial group curve and verifies the monode kinetic model being investigated. From the ongoing, the monode kinetic model seems to be more appropriate based on the experimental data fitted, and as such, table 9 shows the design parameters for the batch anaerobic bioreactor from the experimental data. The volume and capacity of the tank, the total solid content of the substrate, the solid retention time, the pH value of both the substrates and the mixture, the temperature of the bioreactor and heater, the mass of volatile solids, as well as the density of the substrate to be loaded, the density of water and the specific tank operating pressures are part of the design parameters for the batch anaerobic bioreactor gotten from experimental data parameters. From conclusion and recommendations. Conclusion. From the experiment conducted so far, it can be concluded that the percentage weight reduction in volatile suspended solid and chemical oxygen demand were 19.62 and 39.63% respectively of the substrates generated within Ahmadu Bello University after digestion of the slurry, and this indicates the activities of microorganisms, which is decomposition of substrates, and it is also a manifestation of production of biogas. And the cumulative volume of biogas produced was 2.31 liters per gram. The flammability of the produced biogas portrays that 50% or above presence of methane in the produced biogas. Hence, it can be concluded that Ahmadu Bello University Wastewater and sewage sludge can potentially produce biogas in high quantities, giving favorable conditions for the anaerobic reactions to occur. Also, monode kinetic model was more appropriate when experimental lab data of chemical oxygen demand and volatile suspended solid were fitted into the empirical models of Logistic and Contois model to predict the cumulative volume of biogas. In conclusion, the objective to design a batch reactor that utilized the slurry source from Ahmadu Bello University Zaria was made feasible from the design parameters gotten from the experimental data. Recommendations. It is highly recommended that the biogas produced be analyzed for its composition using a gas analyzer in order to check health hazards arising from using poisonous gases such as hydrogen sulfide and sulfur. Also, it is highly recommended that inhibitory studies be carried out on the substrates prior to digester, as this, if unfavorable, can affect and have a negative impact on biogas potentials of the substrates. In addition, adequate digester temperature should be used as well as optimum solid retention times. References. The following are literatures consulted during the course of this research. Please find attached. Thank you, ladies and gentlemen, for listening. Thank you, ladies and gentlemen, for listening. Continue to be safe. May God bless us all and grant us all our heart's desires. Thank you.